So in this video I'm going to go through question 3 from the January 2012 exam paper. Question 3 has two parts. Part A is asking you about describe the principal methods available for integrating the gradually varied flow equation, and then it says discuss the advantages and disadvantages. So in that question, to gain 10 marks, you would need to sort of explain the direct step method and how that works, and discuss the advantages, and then explain the standard step method, and then again explain the advantages and disadvantages. I'm not going to go through in too much detail for that question because you can find the majority of the literature from the notes. So the lecture notes give you a good example of how both methods work, and the lecture notes also cover the advantages and disadvantages. And also in another video I've gone through what the advantages and disadvantages are in brief, but on the VLE in the solutions by Professor Nigel Wright, he also covers the advantages and disadvantages. So that included with a description of each method, the direct step method and the standard step method, will easily gain you 10 marks. So that is a very easy part to that question, and it's mainly just remembering what the two methods are and then writing a brief description about each, and then just giving a couple of advantages and disadvantages, and that will gain you 10 marks for that question. Part B is the analytical part of the question, and this is where I've had some emails from students who don't understand the solution that Professor Nigel Wright has uploaded on the VLE. So the aim is to sort of again produce that solution, but give you a description of what's going on. So the question says the design flood for a river improvement scheme is 12 meters cubed per square per meter, so that's small q. The bed slope is 1 in 500. The Shazee C is 30, and then it says the channel terminates in a weir which can be considered broad crested, and which the relationship between flow per unit width and depth behind the weir is given by this expression. So in the question it's giving you an expression for Q, and then the question goes on to say where H is the sill height of the weir, which in this case is 2.5, and it says determine the type of backwater profile that occurs upstream of the weir and carry out a one-step integration using the direct step method. And in the question it also gives you a delta y of 0.2 meters. So it gives you a sill height, it's given you a relationship for Q, and based on that, on the parameters in the question, you have to do one step of the direct step method. So that's what we're going to do. So first of all, I'm just going to write down the parameters that we know. So small q is 12 meters cubed per square per meter. S is equals to 0.002. C is equals to 30, and delta y, which is given again, is 0.2 meters. In the question it gives you a relationship Q equals 1.5 y minus h to the power 1.5, and it says h is equals to 2.5. So it's saying h is the sill height. So what does that actually mean? So this is the bed of the channel, and then it says it's followed by a broad crested weir. So we've got the weir here, and then again the channel. So the sill height is this height, is the sort of the height of the weir, which is protruding in the flow. So that height is 2.5 meters, and then what you need to calculate is y, which is, so if the water depth is up to here, y will be that. So y will be sill height 2.5 plus this height, so just call it x for now, and that will give you y in total. Yep. And you can work out this y based on this relationship, because you know what q is. H is given. The only parameter in this equation is 1.5 is y, which is unknown, and y is here, is this. So you can calculate what y is. So if I write down that relationship again, so q equals 1.5 y minus h to the 3 over 2 to the 1.5. So if we put in the numbers, 12 equals 1.5, y is unknown, minus 2.5 to the 3 over 2. So the only parameter that is unknown is y. So you can rearrange this equation for y and calculate what y is. So if you rearrange this equation, what you get y equals to h plus 2 over 3 to the power 2 over 3 times small q to the power 2 over 3. Yep. So now you can put in the values. Y equals 2.5 plus 2 over 3 times 12 to the 2 over 3, and that gives you 6.5 meters. So y is equals to 6.5 meters. So what it is saying is that height is 6.5. So it's 2.5 plus 4 equals 6.5. So this height above the weir is 4 meters, and then the sill height is 2.5 meters, and altogether y is 6.5 meters. So that's the first thing you need to do in this question, is to work out what y is. And once you've worked out what y is, you can then start using the direct step equation to do the one-step integration. Now, I've had questions from students regarding the table in the solution. Now, there's a slight error in this question, and that is that in this question it should say that the channel is wide, but it doesn't. So that's an error in this question, because it should state that the channel is wide, so R is equals to Y, because in this question B is not given. So it gets very confusing when B is not given and when it also doesn't state it's a wide channel. Now, because of that, it's very, very difficult to understand what to do, but it's a slight error in the question, and the channel should be assumed to be wide, so this relationship should be taken into account. So if we start creating the table, so first of all I'm going to do so x, just going to draw a line. So x, we start at 0. Y at 0 is 6.5. Yep. And in this question, Professor Nigel Wright sort of gave you what delta y was, and based on that, he's done one step by taking a mean value of y. So what he does is does one step by doing this. So he does 6.5 and then does 6.3, and that's y. Oh god. Yep. So now the next column is y1 plus y2 divided by 2. Yep. So it should be 6.5 plus 6.3. What you get is 12.8 over 2, and what you get is 6.4. Yep. Now the next value he has is v, and he's worked out v by so v equals q over a. Now q is small q times b, and area is b times y. Now the b at the top and the b at the bottom cancel out, so you get left with q over y. So v equals 12 over 6.4, and that gives you 1.875 meters per second. So here you have 1.875. Then he has r. Because it's a wide channel, r is equals to y. So y is 6.4 because we've taken a mean value of y. So r is equals to 6.4. Yep. So this is what I was saying. Because in the question it doesn't say a wide channel, so it makes it a bit difficult to sort of understand what to do. But it should be a wide channel, and r is equals to y, so r is equal to 6.4. And then you've got f of r. F of r is equals to v over square root g y. So you get 1.875 divided by square root of 9.81 times y times 6.4, and then you get 0.2366. So you get 0.2366, and then you got 1 minus f of r squared. So it's 1 minus this value squared. You get 0.944. Then you've got s of f. Then s of f is given by the Chizi equation. So the Chizi equation is q equals a to the c square root r s of f. Now r is equals to y, q is equals to qb, area is b times y. So if I write all that out again, so you get qb, which is q, is equals to area, which is b times y, times c times y to the half, and then sf to the half. Yep. Now the b cancels out, you just get left with the b cancels out, and then you collect this y and then that y. So it's half plus 1, it's 3 over 2. So you get left with Q equals C y to the 3 over 2 times S of f to the half. Rearrange that for S of f. So S of f is equals to Q squared y cubed C squared. Yep. So that's 12 squared 6.4 cubed and then 30 squared. Yep. And your S of f will be 0.00061. And then it's S0 minus S of f. S0 is 0.002. So that gives you 0. So S0 minus S of f 0.0013. Yep. And then finally delta x. Yep. So delta x is equals to delta y 1 minus f of r squared over s naught minus s of f. Yep. So delta x is equals to 0.2. Delta y was given. 1 minus f of r squared is 0.944 divided by 0.00139, and that gives you 130. Oops. So that gives you, 135.8 meters. Yep. So that whole procedure. So initially calculating that 6.5 with that relationship, then setting up the table and calculating 135.8. So calculating all these values of V, R, F of R, 1 minus F of R squared, S of F, S naught minus S of F, and then delta X using the direct step method. And then getting that value would give you the 10 full marks available for this question. The other thing is, in this question, Professor Nigel Wright takes the mean value for y. That is a correct way to do it, but not the only way to do it. If you were to use 6.5 and not use 6.4, and again go through the same procedure, you'd get a different value. You don't get 135, you get a slightly different value, but that answer again would be correct. Yep. So there's various different ways to do the integration method, and most of the ways are to make the final answer more accurate. So sometimes in questions you've seen where S of f, we've taken a mean value of S of f, or we've taken a mean value of 1 minus f of r squared. So that's only just to make the solution more accurate. But if you were to do one row without taking any mean value, that would be correct. So in this question, if you were to miss out this part and just use 6.5, that would also be fine. There would be no problem with that. You'd get a different answer to 135, but that answer would also be correct. But because you have to remember, this method is only a good estimation. Yep. So don't be scared to not go with what the solution says, and just stick with what you've been taught, and be confident in doing the solution. Don't be put off by other methods that have been incorporated by other lecturers, and it's all just to do with making the final solution more accurate. So if you were to do 6.5, calculate V, R, F of R and the rest and get your delta X, it'd be different to that, but it'd be correct. Okay, so that concludes that video, and hopefully that's made that question more easier to understand.